Okay, I guess all have joined. Shall we start?
Yes, you can start.
Yes, please.
Okay, very good afternoon to all of you. I'm Kavita Jaiswal. I'm going to host today's session. On behalf of Department of Computer Science and Engineering, NIT Raipur, and 4th International Conference on Machine Intelligence and Signal Processing, I welcome all the respective session chair and participants. Before we start the session, let me introduce all of our esteemed session chairs. Our first session chair is Dr. Avinash Pandey. Dr. Avinash Pandey is currently working as an assistant professor in the Department of Computer Science and Engineering at Indian Institute of Information Technology, Design and Manufacturing, Jabalpur. He has completed his PhD in Computer Science and Engineering from JP Institute of Information Technology, Noida, and MTech in Computer Science and Engineering from Netaji Subhas Institute of Technology, Delhi. He has more than 8 years of teaching and research experience. He has guided many MTech and BTech projects. He has published more than 30 journals and conference papers in the area of text mining, data mining, and soft computing. He has been an active member of many organizing committees of various conferences and workshops. Thank you, sir, for accepting the invitation and joining this session.
Thank you, ma'am.
Our next session chair is Dr. Pooja Jain. Dr. Pooja Jain is currently working with the Indian Institute of Information Technology, Nagpur, in the Department of Computer Science and Engineering. She has 16 years of experience in industry as well as academy. She has worked with multinational companies like IBM and CSCC. She has many publications in international journals and conferences. Currently, she is involved with a project at DRDO. Thank you, ma'am, for accepting the invitation and joining this session. Our next session chair is Dr. Rakesh K Shukla. Dr. Rakesh K Shukla is BE, MTech, and PhD in Computer Science and Engineering and is having more than 20 years of teaching experience in various engineering institutions on position like head of the department, vice principal, dean. At present, he is director of Oriental Institute of Science and Technology, Bhopal. He is well-known author for books on computer science and engineering and allied courses. He has organized more than 50 international conferences. He has more than 40 research papers published in various international journals and conferences. His 3 patents are granted and 2 patents are published. He was the chair of CSI Bhopal chapter and treasurer of IET Bhopal. He is the founder of chair of ACM Bhopal chapter. Thank you, sir, for accepting the invitation and joining this session.
Thank you, ma'am.
Now let's begin the paper presentation. Before we start the presentation, there are few instructions for the participant. Each participant will get 12 minutes for the presentation, out of which last 2 minutes is for question answer session. So I request all the participants to follow the timeline. And I also request all the session chairs and participants to keep their videos on during the session. I request to session chair to start the session. Over to session chairs.
Yes, you can start.
Okay. Now I invite our first presenter, that is the paper ID 65. Mr. Sandeep Sahu, you can share your screen and start the presentation.
Yes, ma'am. A very good afternoon to respected session chairs and my colleagues. Because all several and this screen sharing.
Pardon, sir, your voice is not clear.
Ma'am, I'm unable to share actually. It is showing in screen host disabled. Attendees
Okay,
screen
let
sharing.
me make you co-host, sir. Okay.
Co-host, yes, ma'am.
So now you can share. Are you able to share?
Yes,
Sir?
ma'am, I can try. Yeah, it is still showing, ma'am, that host disabled attendees screen sharing.
Now you try, sir. I make you co-host.
Yeah. Yes, ma'am. Thank you. Now I think I can share. Yeah, my screen is visible to all. With respect, I'm asking. Am I audible, ma'am?
Yes.
Yes, sir. Everything is.
Go ahead.
Screen is visible. Yeah. Again, a warm good afternoon to all of you, my respected session chairs members. May I continue, sir?
Yeah, please continue.
Yes. My name is Sandeep Sahu. I'm the PhD research scholar at UIT RGPB Bhopal, Madhya Pradesh. And my research paper title was submitted in MISP 2022, a robust distributed clustered fault tolerant scheduling for wireless sensor network. It's namely RDCFT, and my paper ID was 65. So before starting the presentation, I would like to introduce some outlines, some contents of our presentation. The first, I would like to discuss about the background and some introductory part of wireless sensor network and some challenges. Literature survey, then I will turn on some reviews papers which I have gone through that, then problem descriptions, followed by the methodology which I proposed, and some after that simulation results and discussion part. Subsequently, I would discuss at last the conclusion and the references. So since my field of interest and the research field, that's a wireless sensor network, as we know already that it's a collection of sensors which is based on the MEMS technology, that is a micro electrical mechanical system based. These are the tiny sensors with having some sensing, communicating and processing capability as per the type of network. Like homogeneous network, then definitely all sensors having the equal capabilities in all aspects. While I'm talking about the heterogeneity property of wireless sensor network, they may vary according to their sensing, communicating, and the processing capability accordingly. So as per the daily demands and the requests and significance development in the various field and the applications and these technologies, sensor networks plays a very important role. These destinations contribute to the development of also. So since our topic inside the wireless sensor network, that's a fault tolerant. So we are going to achieve in our this research work ultimately proposed work that's a fault tolerant method of fault tolerant scheduling for the wireless sensor network. So typically a wireless sensor networks monitors or operates a remote or the hazardous locations or some remote locations where they require the highly reliable and fault tolerant architecture. So the fundamental keywords are the key concern in the wireless sensor network is whether the principal consequences of battery depletions are the energy shortage, are the sensors failures, are the exchange of erroneous information among sensors. So ultimately, all sensors are deployed with in the remote location with the battery dependent, since that the battery is having the limited lifetime. So sometimes in the remote location or the hazardous location, they may fail before their expected lifetime. Results, enhanced fault tolerance capabilities in wireless sensor network results in increased sensor residual lives. Due to its necessity, the sensor must withstand failure and transmit accurate data to the base station according to reference number 1. Even in the presence of fault, a fault tolerant framework or the network architecture will continue the administrate itself. So overall network should continue in the presence of even the fault. This is the fault tolerance capacity of any network. As a result, of fault tolerant framework require the several conditions. Some sensors fail to operate after their estimated battery life has expired, reducing the network's total lifespan and functionality. Numerous researchers have made a very significant contribution to fault-related obstacles such as the sensor failures, coverage, connectivity issues, network partitioning, data delivery inaccuracy, and dynamic routing, and sensor scheduling, among all. So due to the unpredictability, this wireless sensor network, designing the fault tolerance technique is one of the critical and crucial issue. Numerous researchers have suggested numerous solutions based on the routing, scheduling, and energy to overcome the prevalence of the wireless sensor network faults in the literatures. Clustering and scheduling, there are two things which we have concluded are taken the keywords of our research paper. The clustering and scheduling are the most commonly used energy efficient and fault tolerant management techniques together in wireless sensor networks. So what does it mean? Actually, it's grouping sensors to manage them and or perform distributed activities such as the resource management. Although clustering and scheduling methods are most commonly used to reduce energy consumptions, they can also be used to achieve various quality-driven goals such as the network fault tolerance capability. So the fault tolerance capability, once again, of the network typically include the redundancy and the diversity mechanisms. So here in our research work, we would use the redundancy concept. So as a network management challenges, clustering methods should tolerate malfunctioning sensors while maintaining the network's coverage, longevity, and the sensor stability. Sensors are prone to fail due to their operation in hostile environments, as we have discussed already with the limited battery power or resources, or none of the resources, battery resources, power resources. So the state of the standard sensors or any cluster head can be either active. These are the states basically a sensor node can be residing in the region of interest or the target region where we want to deploy these sensors to form a network. They can be either active state, these are totally a functionality with redundant. They may have the redundancy on the basis of in upcoming slides I would discuss how to identify or whether a sensor node is redundant or not for the particular area, or similarly, or it can be dead or faulty due to any reason for the same target region of interest, that is R symbolic. So the network's overall lifetime and the fault tolerance capability can also be extended by using these backup sensors. We proposed robust distributed clustered fault tolerance scheduling, which is named by RDCFT approach that efficiently checks the status of the deployed sensor periodically. These sensor can be a standard sensor deployed, a normal member, or can say a cluster head also. And that definitely redundancy can be checked based on the sweep-line redundancy check algorithm, which was proposed in my last journal paper, which were accepted in December 2021 and published in January. So just I proceed this research work into the some other aspect of wireless sensor network application. Finally, simulation results are based on the analytical and explained studies to validate the effectiveness and useful of the proposed work. So these are the literature survey. If you allow me, sir, so I would go with due to time constraints. Actually, I have to cover many slides. So may I cover the main part of the survey literature where I focus, sir? Ma'am, with respect.
Please go to the proposed work. I think.
Yes. Yeah. Proposed work. So just I would take only 1 minute, sir. In the literature part, basically clustering and the scheduling. These are the two keywords which I have been observing since last 2 and 3 years in my research work in the field of wireless sensor network. I was working in the coverage, energy, and fault tolerant issues in wireless sensor network previously. Now just I picked these two words, and clustering and the scheduling. With this help to concept, me and my guide would try to provide the fault tolerant capability. So as a literature survey only, I just picked the redundancy for the sweep-line algorithm, which was proposed in 2008 by the one of IIT Guwahati professors. So just I proceeded, and the cluster had procedure, just I followed the leech for comparison purpose. So this is the problem description. The active sensors major source of energy is limited battery capacity. After sensors are deployed in the R, that is again the target region or the deployment region, they are not easily rechargeable, changeable, or as it might say that nearly impossible to replace. This is the main constraint to make the fault tolerant enough capable this wireless sensor network. So certain applications require a high coverage quality and an extended network lifetime. So due to the sensor network's inability to meet the required level of coverage and quality of service due to inefficient sensor scheduling, the network's operational life is cut short to the reduced. So 7, 8, these are the two base papers where I have proceeded the last recent research work. We have extended the article proposed in 8 and the proposed robust distributed clustered fault tolerant scheduling, which is based on the redundancy check algorithm, sweep-line approach, and that provide the number of redundant sensor for R. So the proposed RDFC determine the one coverage requirement precisely and fast while ensuring the sensor redundancy eligibility criterion at low cost and with better fault tolerance capability at the sensor and cluster level fault detection and replacement. Additionally, we simulate and analyze the suggested works, correctness, and efficiency in various simulation situations. So this is the methodology. So all sensors have been deployed and they are formed a network while exchanging the hello message, and they usually connect through the one of the routing protocol. We usually use some AODB or any dynamic source routing protocol. So a sensor can be called a redundant if the sweep line, what is the concept of the sweep line. So it ultimately took the keyword from the sweeping methods. Like if you are 100% area covered by one of our one hope sensor networks, so therefore I can say like I am a redundant. So this is the flow chart for the proposed algorithms. Just I took as a base paper from that proposed in article 7 and 8. So a sensor node SJ is redundant for one coverage if one hope active sensor networks cover the entire 360-degree angle around the sensor SJ, which I was just telling. It's a one hope means like the range between the sensing range and how many sensors of the one area. If any sensor that also introduced like SJ is a one of sensor who can calculate with the help of this, its entire area 360 is covered by its one hope never. So it can be clearly said as it is a redundant. So more clearly, the union of the all sectors contributed by the sensor in its neighborhood to cover the entire 360 is defined as a redundant criteria of a sensor SJ for one coverage. Hence, their sensor SJ is the redundant one. So this is the algorithm and flow chart. We can go through that. So algorithm, it can be done using an extended version of the sweep line based algorithm for redundancy checkup. Suppose that an imaginary vertical line is sweeping these intervals from 0 to 360. If the is the cable terminology in this last journal in the wireless personal communication in the January 2022. So I have already mentioned this 7 and 8. Maintain a variable CC that's coverage quotient values to keep the current never.
Sorry to disturb you, but your voice is not audible.
One remains greater than or equal to the CCQ, so the sweep line duration. The SJ circular, as in item, sir, a sensor node can be reset. So Diksha.
Yeah, now it's fine.
Sir, now voice is audible.
Yeah, now it's fine.
Sir, now is my voice is audible?
Yeah,
Yeah,
better
thank
now.
you, sir. So this is the thank you, sir. So figure shows the transition state of a diagram. So any sensor node can be residing any one of the state. Either it could be active. Active means the fully functionally, like sensing and communicating the neighborhoods and ultimately doing the application task as per the based on the application requirement. Pre-sleep, it is a state when it is about to identify itself like I am in the redundant one. So it before going the direct sleep mode, it can it has to be stay for a period that's called the pre-sleep, or can say the idle state, and finally a sleep state. So this sleeping, basically I use the already functioning in the simulator, that's a backup timer. So this is the, sir, again selection of the cluster head nozzle. So ultimately on the basis of energy, again as usually the least protocol also use this concept which become the ultimately cluster heads on the basis of the remaining energy, which one having the highest remaining energy it becomes. So again, this is the all cluster head is chosen randomly by the base station among the clusters members. The first then cluster heads in this is the deployment time, the initially first, because every sensor having the equal. So which one becomes, so it is the random in the first time, and the second round, third round, and up to the nth round, according to the total network life of the network, we choose this cluster head on the basis of the remaining energy. So this cluster head is responsible to communicate the all respected base station and the cluster members and other cluster heads also. Cluster heads will be created according to the hierarchy that had been established, and the cluster heads grows with each round. The hierarchy is built. The first round cluster will be node at the first most considerable energy storage capacity. The second round includes the node with the second highest level, and so on. And it will continue likewise till the network is about to live. So this is the final main methodology or the proposed method which we proposed, followed by the base paper which is published already in January. So that was also mind paper, me and my guide. So I just extended while applying the clustering on that paper. Scheduling already proposed on that paper, but clustering was not there. So just I put in there. So input as a set of random deployment nodes. So the deployment procedure, this is the prerequisites I forgot to tell. This completely wireless sensor network is a homogeneous, the first criterion, and second criterion presumptions that every node having the equal capability and they are deployed randomly. So the deployment can be done either in the random as a deterministic way. So we use randomly because easier and cheaper in the target trees. So these are the cluster heads we can found, cluster 1, cluster 2. It depends on the how many clusters are there in a particular area. Process, configure the sensor into the cluster and also find their redundant eligibility for the backup. So again, as a matter of fact, why we are targeting, why we were focusing in the redundancy. So redundancy is one of the finest approach to provide the fault tolerance capability, because since in the hostile where the redeployment or the exchange or the recharging is not possible. So existing node we are already covering that the same area. So that the idea and concept came from that. So the process, configure all. So backup sensor cluster head. So process is the random selection of the temporal CH for the first network round and ask for the remaining cluster members to check their energy level. And finally, the output, the selection of the sensor node at the cluster head, set of cluster heads, set of the faulty sensors as well as. So initialize, random selection, temporal. Yes, ma'am.
Can you complete your presentation in 1 minute? Actually, time is over.
Sure, ma'am. So yeah, ma'am, sure. So this is the ultimately all scheduling done on the basis of their energy and current status of the network. So here the key point again I would like to discuss about the overall research methodology. We use again the clustering and as well as the redundancy. The redundancy we already discussed in that last journal where we implemented the algorithm. We just extended while applying the clustering. So clustering in this method. So this is the again result and discussion. The section demonstrates the experimental setup and shows the result of the proposed algorithm. We evaluated the performance of the proposed algorithm using the network simulator, that is the NS2. This is the some scenario we have taken, like 100, 200, 300, and some random deployment of networks nodes. Area we have chosen like 100 by 100 meters squares. Clusters differs according to the size of network and the size of values of ultimately sensor nodes. Distributed subregion 30 by 30 we have taken already. Initial values, that's a 10 joules. This is just parameter we have chosen in the simulation time. Initial energy consumption for transmission 0.02 joules and the energy consumption for receiving the signal or message 0.001 joules. It's quite obvious. It has been proposed in many journals, like it's a very lesser than the transmitting. So communication sensing rays 4 meter and 3 meter vice versa. Threshold energy for each 2 joule and the simulation time 1000 to 1500 seconds and for the 200 rounds. So this is the scenario in the left most image, which is the cluster head and some sync nodes in dotted form. And right hand side, this is the 30 by 30 that the sub-regions are the distributed sub-regions. These are the results, basically how the average alive sensors with the proposed methods and how many average alive sensors with the randomized. So just initially I was discussed and I was comparing, we were comparing our work with the randomized. If I choose without clustering or random clustering methods, so definitely this will differ. So our algorithm was properly. So as a simulation result represent the average number of alive nodes and the for the ROI compared with the randomized. And the second figure of the result, that's average faulty cluster head nodes, is the number of faulty nodes identified in our algorithms, and average faulty nodes, normal nodes, these are red symbols, and the green, the average faulty nodes for the all deployed sensors. This is again the comparison for the backup cluster heads and active nodes. This is the comparison of the first one graph, and the second one graph, this is the comparison slightly, because I have not gone through the much more recent work close to this work, because I was using the redundancy concept. So the many publication not related to that. That's why just I compared this clustering and redundancy concept, scheduling with the help of scheduling method with this leech protocol and randomize. So this is the comparison how we efficiently work the number of rounds and how many number of live nodes. So this is the simulation. And finally, just last 30 seconds, in 30 seconds, I would like to conclude my work. So proposed approach is based on the redundancy of the sensor and cluster heads. This clustering approach maximizes the longevity of the network. The proposed method begins with the detecting defects and can find faulty sensor nodes using the fault detection algorithm and replace the faulty sensors by the sensor for the same arc. Subsequently, the algorithm wise and log and AND, it takes to check the eligibility criteria, whether it's a redundant or not. And at last, the last statement, our proposed works are based on the primarily two-dimensional based on the architecture with the homogeneity. The future work definitely should be extended the 3D networks of the wireless sensor network, as well as the dynamicity will be added. So future research work will also cover the crucial issues like energy coverage fault in 3D networks, which help in the new way to research in sustainable wireless sensor network with the maximum total network lifetime. These are the references. I have taken around 16 references. That's 7th and 8th number. That's a Sweeplan algorithm 7th number and 8th number, which we just published in Wireless Personal Communication Springer Journal, and we extended with the help of this one. Thank you, every respected session chair member. Am I audible, ma'am?
One question. Why you have chosen leech?
Yes, sir.
Any reason behind this? Any specific reason for choosing leech?
Leech, sir, you are talking about?
Yes, leech.
Yeah, sir. Actually, my objective work behind it, the total coverage and redundancy. I was just trying to apply the clustering. So the very famous and known protocol, that's a leech low energy consumption clustering protocol. So that's why, sir, I prefer to use it. But I couldn't examine much more on the basis of new recently leech versions. There are many versions of leech protocol, but I just compared it.
Many recent versions are also available. That's why I asked
yes,
this question.
Yes. That's why, sir. It's a traditional approach to compare. Actually, that's why I couldn't extend it because the redundancy and coverage added on my work. That's why. Thank you, sir.
Yeah, one more question. Whether the throughput of your system will increase if you are talking about the fault tolerant system. So in fault tolerant system, some of the nodes may be dead. So in that case, what will happen about how the you can say the throughput of your system will be there, whether it will increase or decrease or it will be constant?
Sir, according to application, according to scenario. Yes, sir, I got almost your questions. So just I'm trying to address, sir. Sir, actually many application according to day by day daily needs. Okay, so many like IoT is a wireless sensor network. Also, the IoT is a wireless sensor network application since in many domains. So as a matter of fact, like sir, like in sensitive areas like military or the LOC line of control or some wild area of South Africa lies, and there are many applications where we need to focus in two things, like the longevity of the, as long as possible we can extend the network total lifetime, along with the fault tolerance capability of the network. So this is the main reason or the main contribution why we were focusing on that work. So we want to enhance the total network lifetime, sir, in order to perform in a better way, as well as the fault tolerance is the additional but very important and crucial aspect in any wireless sensor network or any system. So it is the capability in the presence of any fault or any type of fault, system should continue. Our system should sustainable. That is only the reason, sir. We continued it.
Okay. That's all from my side.
Thank you, sir.
Sandeep,
thank you so much, sir.
Sandeep, how you are dealing with the high frequency of reclustering? Because fault tolerant routing these protocols generally suffer from this deficiency, that is high frequency of reclustering that will consume extra energy.
Yes.
So how you are dealing with this?
Sir, actually, I have gone through the simulator and the some predefined parameters and some experimental parameters I have taken. So this part is not actually I have much more covered, but again, I should address, sir. I must address this question. The reason behind it's a reclustering. Actually, I was using the cluster had procedure also on the basis of energy, remaining energy criteria. So it's just a comparison formula I have put over there in my algorithm. So this is only the, but reclustering actually I couldn't approach much more, sir. In upcoming future work, definitely I will address it.
Yes, yes. Actually, many cluster-based fault-tolerant routing protocol have been proposed for energy conservation.
Ji sir, you are absolutely right. Yes, sir.
Yes.
Exactly, sir. Yeah, yes, sir. Agree with you,
sir. What is the basis? What is the basis for forming the cluster?
Basis.
On what basis?
Yes,
you
sir.
are forming the cluster
Energy consumption. Overall energy consumption. Right. Overall energy and actually ultimately reducing the energy consumption at the every sensor node level, and ultimately we are extending the overall network lifetime, average network lifetime.
Okay, fine.
Thank you so much, sir. Thank you so much, sir.
Sandeep, the thing is you are giving a presentation. So in the case of the presentation, you should not copy paste the paper. You have copy pasted the paper throughout. You have even copy pasted your paper in the related work. It should be in the form of a presentation.
But keywords. Yes, ma'am. I apologize for the
it should
same.
Be in the form of a presentation, and you should not copy paste it from the paper. In fact, in the slide you have mentioned, in the paper we talk about so and so. This is not a paper. This is a presentation. Okay, so you should always keep it in mind that when you are presenting, it should be very crisp and in a bulleted format.
Sure, ma'am.
So that the others can also.
Sure, ma'am. Next time I will. Yeah, ma'am. Sure, ma'am. Thank you for this concern, and I will definitely next time keep in mind.
Yes.
Thank you, ma'am.
And the second thing is I want to just continue with what Dr. Avinash said. Regarding you are saying that you want to go for a fault tolerant system, so you're not considering the cost at this time, because if you are taking redundant nodes, then definitely the cost would be very high.
Yes, ma'am.
So cost is not the criteria in this case, because wireless sensor networks always have this
no,
problem that the cost of the network is increasing.
Yes, ma'am. The cost actually we didn't consider in our total our entire research work, ma'am. The cost actually we deploy the sensor in the random order and this densely, so that the redundancy can be increased, ma'am. This is another reason why the redundancy criteria chosen over here.
Okay, because whenever we are structuring the wireless sensor network, the major concern is energy, and the second one is the cost. How can we reduce the cost, and how can we reduce the energy? And if the cost is not a constraint, then you can do anything. You can involve so many sensors that there won't be any fault tolerance. There won't be any of the sensors.
Sure, ma'am. Sure, ma'am. That's why, ma'am, Pooja ma'am, actually I have taken some keywords and some applications oriented, like sensitive application where the cost doesn't matter, even the security or the fault tolerance is much more important, even the longevity.
When you would be completing your PhD and when you are choosing the topic for the PhD, then choose it in such a manner so that the application, whichever you are choosing, doesn't depend upon the cost.
Thank you so much, ma'am. Yes, ma'am.
Okay.
Thank you so much for your valuable feedback and appreciation. Thank you so much. Thank you.
Okay,
may I stop sharing?
Sandeep. You can unshare your screen and be online.
May I stop sharing?
The session is over.
Yeah. May I stop the screen sharing, ma'am?
Yeah, sure. Now, our next presenter is the paper ID 168. Miss Mahalakshmi, you can share your screen and start the presentation. Ma'am, unmute yourself.
Good afternoon all. I and here's my project, myself here Mahalakshmi, representing good improvements with low latency in data center network.
Ma'am, your voice is very low. Can you speak loudly?
First, we'll just get through into the background of the project. Data center is used for large data storage in various industries and organizations. The data traversing from source to destination is a process of data center network, which we all know. In the recent year, there are many modified TCP protocols that are used. One of the modified TCP protocol named Multipath Transmission Control Protocol, which is efficient for DCN. This protocol has multiple paths for data transferring. MPTCP is highly suitable for large volume of data packets and not efficient for transferring a small volume of data packets. The transmission of small and large volume of data packets takes equal time. So there is a probability of latency in time. The MPTCP issues are eliminated by a proposed enhanced multipath transmission control protocol. This protocol further adds a packet sprinkling method to resolve the issues like low data transmission, timeout, and latency of MPTCP. By means of packet sprinkling, which focuses on sending a small volume of data packets effectively. It is also MPTCP, as already we have seen, is efficient for the large volume of data packets. This entire implementation is done in NS2 for evaluating the proposed protocol, and the results showed that EMTCP is better than MPTCP. This is my literature survey work done. The first paper is on data center TCP. The inference which I received in this paper is to achieve the performance image, TCP and DCN has been adopted. It tries to avoid packet loss. DC-TCP have the properties of stability, convergence, and fairness to suit
Ma'am, your presentation has got stuck. Kindly check your connection. Miss Mahalakshmi, are you there?
I think she is disconnected. Please check.
Okay.
Ma'am, am I audible, ma'am?
Yeah, you are audible, but your screen is not visible. Can you share your screen?
Yes, ma'am. Yes, ma'am. I'm really sorry for the inconvenience due to some power failure. So let me continue from where I stopped. So the next paper is on in-class congestion control for TCP in data center networks. This IC-TCP does not need any alteration at the sender side, only at the receiver side. The TCP performance for TCP in-class congestion problem is improved by this IC-TCP in data center networks. IC-TCP assumes same switches in sender and receiver side, so does not know how much buffer space is used by IC-TCP. The deadline-aware data center TCP. D2 TCP easily deploys to avoid TCP incast, queue buildup, and high burst tolerance because it is built upon based on the DC TCP. And also it is deadline aware compared with DC TCP. The missed deadlines minimizes up to 75%. The next paper which I taken was minimizing flow completion times in data centers. L2DCT, same behavior as DC-TCP. L2DCT minimizing the flow completion time and solves the latency issues in data centers. L2DCT does not have the deadline awareness, it does not have any flow size information, it does not give any superior precedence to more urgent flow. And the last paper which I got through is adaptive marketing threshold method for delay sensitive TCP in data center network. The adaptive marketing threshold which proactively tunes the marketing threshold to eliminate the unnecessary queuing delay and maintains high link utilization at the same time. These are the 5 major papers out of all the reference paper which I have taken for paper study. So entirely the problem description is around incast congestion affects the TCP flow completion time and throughput. MPTCP have a problem in incast collapse where the receiver suffers a drastic goodput drop when it simultaneously requests data over multiple servers. Minimizing the flow completion time and improve the TCP throughput using enhanced multipath transmission control protocol is our objective. So here comes our methodology. First, we have used a multipath TCP. As I already said, is an extension of TCP that transfers data through multiple paths simultaneously. It actively senses network congestion for all its subflows and shifts traffic from more or less to congested paths. ECMP equal cost multipath provides a weighted congestion control for MPTCP at the sender side. Packet scatter is the next methodology used. Specific amount of data is randomly scattered as packets in the network under a single congestion window, exploiting all the available paths. Fast retransmit algorithms to deal with out of order packets. And here is our approach, proposed approach of enhanced multipath transmission control protocol, which combines PS and MPTCP. Initial subflow is only allowed to scatter packets in the network during the first phase of packet splitting. After a specific amount of data is sent, EMPTCP switches to regular multipath TCP mode. No more packets are put in the initial subflow, which is deactivated when its window gets emptied. So this is the implementation. For the first step, data packets are sent from the source at first, and the step 2, at first a small volume data packets, which is less than 300 KB, will be sending from source to destination in the single path with single congestion window with the help of packet sprinkling method. And then step 3, then it shut down the packet sprinkling process and then goes to step 4, where the large volume of the data packets is sent within a fixed amount of time from source to destination using multipath with the help of MPTCP. And finally, all packets are received from the destination within the predefined timer. These are the results which I have observed. First, the goodput comparison for MPTCP and EMPTCP. Based on hotspot degree and goodput value is shown on the table. Goodput is calculated by the ratio of number of packets delivered to the total delivery time, and it is observed that EMPTCP have high goodput value than MPTCP. And next parameter chosen is core layer loss rate comparison for MPTCP and EMPTCP. When packets are lost after a core layer, it is called as a core layer rate. The packet loss rate is calculated by the ratio of a number of lost packets to the number of received packets. The core layer loss rate of EMPTCP is lesser than MPTCP. And the final parameter is finishing time comparison. The mean finishing time comparison between MPTCP and EMPTCP is shown in the table. This MPTCP and EMPTCP protocols finishing times are compared with a fixed amount of hotspot degree, and it is observed that EMPTCP finishing time is faster than MPTCP. So EMPTCP is efficient for data transfer. The overall comparison of all the 3 parameters like finish time, goodput, and core layer cost rate for MPTCP and EMPTCP based on the mean value is shown in the table. During our performance analysis, enhanced multipath TCP is efficient for transferring data packets in data center network. EMPTCP have achieved high goodput, low packet loss rate, and low latency. Thus, the conclusion is packet sprinkling method is additionally added for MPTCP mechanism. Thus, the enhanced EMPTCP protocol proposed. MPTCP, as I already said, has shown an effectiveness for a large volume of data packets, whereas packet sprinkling is efficient for small volume of data packets. Taking up the two advantages, EMP-TCP achieves a high goodput for a large volume of data packets and low time delay for small volume of data packets. Enhanced EMP-TCP reduce the traffic for data flows and improve the throughput. Small volume data packets are sent to the packet sprinkling method, so less time is taken for packet wrapping. Overall, EMP-TCP has better performance than the data center network protocols such as TCP, DCP-TCP, and NP-TCP. And these are the reference papers which I have referred for the work. Thank you, ma'am. Thank you, chat members. Any questions?
Yes, Mahalakshmi. Mahalakshmi, first of all, just a suggestion from my side. Whenever you are giving a presentation, you're not supposed to read from the slides. So you should always mention it in your own words.
Okay.
Okay? And secondly,
sure.
you are always using the word goodput. So how do you differentiate goodput from throughput?
Goodput is something like a number of data packets and the total time taken for that entire data packets to be delivered, whereas throughput is like within a second how many number of data packets have been transferred. Within
So
a
you said
second
the same thing for goodput also. Goodput also says the same thing, na?
Yeah, ma'am. Moreover, it could resemble, ma'am.
No, it's not the same. They are different. Goodput is different from throughput.
Yes,
so when you are giving the results, you are talking about goodput. So is it throughput or it is goodput?
It's about goodput, ma'am.
You are not able to define goodput, then how can you say it is goodput?
Goodput is what I have seen through is a number of packets that has been delivered with and to the total number of time it like transferring time.
That is throughput, dear Mahalakshmi. That is throughput. Number of packets delivered per second is throughput.
Okay, ma'am. I'm sorry.
Goodput is the meaningful packet. Goodput means the meaningful packet. How many meaningful packets are delivered in a second? So when you say goodput, then you should be able to identify that the packet which has been delivered is meaningful or not.
Yes.
So in fact, your simulation results will change. You have to mention throughput and not goodput there.
Okay, ma'am. Okay. Okay, sure. I'll work on it. Yes, ma'am.
Okay. That's it from my side.
Yes, ma'am.
How you implemented this protocol?
Sir?
How you implemented your protocol?
Using NS2 simulators. NS2.
Okay, so the protocol that you proposed is connection oriented or connectionless?
Sir, I'm not clear.
The protocol that you propose is connection oriented or connectionless?
Connection oriented.
Connection oriented. Okay.
Yes.
And how you are comparing your system with the existing or literature? You are taking goodput that or throughput.
Yes, sir.
Only one parameter you are taking for comparison. Is there any other parameter that can be used for comparison?
Yes, sir. I'll work on it. Till now, I just this is a base work which I have started 2 months back, so I couldn't work further on it. I'll just go through it, sir. I didn't I didn't compare with the more literature survey papers. I took a general work as a mini project and I proceeded, sir. I'll work on it.
Please explore some other parameter that can also be used for comparing the two protocols. Because on the basis of throughput or the goodput, you are saying that this protocol is better than the other protocol. So you need to use some other parameters also. Because as per my opinion, only one parameter will not be sufficient. So please.
Okay.
So that's all from my side.
Okay, sir. Sure, sir. Thank you, sir.
Lakshmi, whether it is manages all the protocols from the receiver end as well as on this from the sender end?
Yes, sir. It manages from the receiver side and the
Is it?
Yes, sir. Yes, sir. It manages on both the sides, sir. Yes.
Okay, thank you, Ms. Mahalashmi. Now I'd like to invite our next presenter, that is paper ID 288, Mr. T.N. Suresh. You can share your screen and start the presentation.
Okay, madam. Okay. Visible the screen, madam? Visible the screen?
Yeah.
Please?
Yes, sir. Go ahead.
Yes. Good afternoon to all. So my name is T.N. Suresh Babu, research scholar, Anna University, under the guidance of Dr. D. Sivakumar, Professor, Eastwar Engineering College, Chennai. My title is Modernizing Patch Antenna Wearables for 5G Applications. So these are my presentation contents: background, literature survey, problem description, methodology, result and discussions, conclusion, and references. The intensive research into fifth generation technology is a strong insignia of the methodological revolutionary to support the emergent demand and requirements of wireless broadband and IoT based applications. Not only for smartphones, the IoT devices will support the 5G technologies to enable for faster transmission speed, lower latency, and therefore increased remote execution capacity. So here I propose the wearable technology. So wearable technology is here growing more desirable for variety of applications in the area of the military, consumable, healthcare. So in that wearable technology, there will be play a crucial role in the next 5G networks. So due to provide higher bit rates, fewer outages, and a broader coverage area than previous technologies. So in that fifth generation technology, we consider the bands. Either
your slides are not moving, I think.
Sir?
Your slides are not changing.
No, sir. I'm just telling background. Yes. Sir, can I continue, sir? So in that 5G technologies, yes. Yeah. So in that 5G technologies, we are concentrating.
The slides are not.
Sir, the same slide I explaining the background.
Okay.
So in that 5G technologies, we are having two bands. One is the sub 6 GHz bands and beyond 6 GHz bands. So the 5G technology cover both sub 6 GHz bands and also your beyond 6 GHz bands. So the beyond 6 GHz bands is called a millimeter wave. So my proposed antenna is a variable antenna. So to design that variable antenna in 5G communications, we considered these points, the parametrics, communication topologies, component design and paradigms, and also the considered the materials, fabrication methods, and assessment procedures. The fabrication process has improved as the antenna has progressed from simple microstrip or planar monopole based topologies to more advanced arrays and metamaterial based topologies. So nowadays we are using that design that variable antennas. We use some technologies, laser cutting, embroidery, metallized highlights, and inkjet printing, and other techniques are projected for higher frequency operations. So in that variable antennas, we considered another one analysis here. SAR analysis, deformant studies on detailed human phantoms, reliability studies, functionality test, and operation under a variety of environmental circumstances. So this is my literature survey regarding the wearable antenna, both sub 6 GHz and beyond 6 GHz. Zhao H. et al. Proposed a compact FR4 framed integrated MIMO antenna for wearable applications, covered two bands, 4.9 GHz and 5.2 GHz. Day-2 et al. Proposed a compact liquid crystal polymer-based tri-band flexible antenna for wearable applications, only coverage of the three bands, 2.4 GHz and 3.5 GHz and 4.8 GHz. The third one is a Kamrania et al. Proposed a bus-shaped tri-band antenna on flexible PET substrate, coverage only the 5.5 GHz sub-gigahertz applications. The Muscat Alam et al. Proposed another one technique is a meta-surface enabled hepta band, coverage of 7 bands. The last one is a X et al. Proposed hexagonal shaped CPW feed-based frequency carrier configured antenna using FR4 substrate, coverage only the sub-6 GHz. So from this literature survey, I have that antenna designed only sub-gigahertz. So here, Liveway et al. Proposed a compact UW MIMO antenna using the FR4 substrate, coverage of UWB range 3.3 to 10.9 GHz. Casimir et al. Proposed UWB nanocellulose coconut coir fiber insulated antenna with a artificial magnetic conductors. Yes, sir.
Your slides are not moving. I think you are at first slide.
So this is a literature survey slide, sir.
No, I can't see.
Yeah, 1 minute, sir.
Is it visible to other? No, now it's literature survey. Now we move to the literature survey. Yeah, that's
yes.
So
yes, moving, sir.
That is what I was asking.
Yes,
now
sir.
it is moving.
Sir, now moving? Okay, sir. Okay. Sir, yes. I proposed the antenna is that antenna cover both sub-gigahertz and also beyond 6 GHz. So coverage of less than 6 GHz band and also a millimeter band, sir. So this is a methodology. My proposed antenna is a compact tetraband wearable textile antenna using the gene substrate developed for sub-5G and beyond 5G applications using the meta-surface ground plane. So here my antenna, I analyzed my antenna by using the CST Microwave Studio software. So many parameters like return loss, radiation patterns, peak gain, and also in various bending conditions, I analyze my wearable antenna. So furthermore, the antenna performance is evaluated at various body locations and the specific absorption ratio, SAR performance is modeled using the CS3. So this is my antenna, 5G antenna, including sub-gigahertz and beyond sub-gigahertz. This antenna design, the antenna is developed on a 1.8 millimeter thick gene substrate with a permeability of 1.6. The overall dimensions are 30 millimeter into 42 millimeter. So an inductive meta-surface ground is made of free 5x4 array of periodic square copper patches, each measuring 5x5 millimeter on the substrate. So this is the evolution of the proposed patch antenna. So initially, I start my antenna as a patch antenna using the transmission line model. The size is 15 x 17 mm. Yeah, first step is here. Antenna one is a normal patch antenna. So which gives gives only one band, 6.5 GHz. So after that, I incorporating 2 rectangular parasitic patches below the patch. So I got 3 bands. So after that, 2 L-shaped strips in that second model and also a third model. Finally, I optimized my proposed antenna. I got 4 bands. So these are the simulation results regarding my antennas using the CST software, CST simulation software. So in that simulation results, the S11 is a return loss versus frequency. So I got 4 bands, 1.9 to 2.4, a sub-6 GHz. Is a impedance bandwidth is a 24.7. The second one is the very important one, 3.4 to 4.2, coverage of resonance frequency 3.5 is a sub-6 GHz 5G applications. The third one is the 19 to 21. The fourth one is the 24 to 30 GHz. This is a millimeter wave application bands, is having the bandwidth 23.25%. So this is the VSWR versus the frequencies. So these bands provide the S11 less than minus 10 dB. That means what? Maximum of the powers are received, maybe transmitted and received by the antenna. So this is the gain radiation pattern of my proposed antenna in that different frequency bands, 4 frequency bands having 2.2 dBi and 4.353 dBi and 8.05 dBi and 9.15 dBi for my proposed antenna frequency bands. So this is the directive gain pattern for the 4 bands, the 2 sub-gigahertz bands and another 2 beyond 6 gigahertz band. So these are the surface current distribution of my proposed antenna for different frequency bands. So in that sub-6 gigahertz band is 2.092 and 3.925. The current distributions dominated in main patch and also a parasitic patch. But in the high frequency range, beyond 6 gigahertz in the millimeter side, the maximum, the current distributions occupied in that ground, also a main patch. So this is the another one performance testing, is a bending performance. So in that bending performance, my proposed antenna bended and the radius of 8 mm, 10 mm, and 12 mm. So in that bending condition, that antenna having the return loss less than 10 dB, and also given the 4 bands, right? 2 sub-gigahertz and 2 beyond 6 gigahertz band. So this is the on-body performance. It's a SIR analysis. So SIR is a critical criterion for determining the amount of electromagnetic field consumed by human tissues. So here I consider the human tissues with their electrical properties, relative permittivity, conductivity, mass density, and thickness, consisting of skin, fat, muscle, with SIR distribution of 27.28 gigahertz. I consider a millimeter wave band with an input power of 0.1 watt. At the height of 2 mm from the tissue surface, the antenna is positioned. The peak 1 gram SIR value for the patch alone is 1.16 watt per kg, which is less than a standard kg 2 watt per kg according to the simulators or distributions. So this is my conclusion. So my proposed wearable textile metasurface ground-based patch antenna for millimeter wave application is presented, explored, evaluated, and simulated in this work. The topic of metric optimization for various antenna settings has been thoroughly studied. The VSWR less than 2 and return loss S11 response better than minus 10 dB can be achieved 4 bands, 2 sub 6 gigahertz band and 2 beyond 6 gigahertz band. Both are 5G applications. The antenna design shown in this article is a potential to be very useful in 5G technology. The antenna has a fair gain and good radiation characteristics according to the simulation findings. The measured result, the simulator results reveals that the addition to meeting SIR criteria, the antenna is still good matching and radiation patterns are the desired operating frequencies. So these are my references, sir. So thank you, sir. So any questions, sir? Hello.
Okay, so how to compute SAR value?
Sir?
How to compute SAR value?
Complete?
How to compute SAR, SAR?
SAR, specific absorption here, sir. Less than 2 watt per kg is a very important one, sir. Beyond 2 watt per kg is a danger for our human body. So, testing on the body, just consider here the height of 2 millimeter here I simulated. So I got 1.16 watt per kg, sir, which is less than 2 watt per kg. There is no problem, I think, not danger. Yes,
okay, sir. Could you please tell me what is the frequency distribution for 4G and 3G?
Frequency 4G is bits per second. Is in that 5G. The downloaded bits is 1 gigabits range, I think, 5G side. Yes, sir.
And what for 3G?
Sir?
And for 3G?
4G, yes.
For 3G?
3G. The downloaded bit rate is less compared to 5G. I think megabits range. Yes.
Okay.
Megabits per data. Okay. So 5G we go for the gigabits per data, sir.
Okay, thank you.
Okay.
Okay.
No question from my side.
Okay, sir. Thank you, sir.
From me as well.
Okay, sir. Thank you. Thank you.
Okay. Now I would like to invite our next presenter. That is the paper ID 310.
Ma'am, how many presentations are there?
One more left, ma'am. Total 2 are left.
This is the last one?
No, this is last set, second.
Okay.
Mr. Suresh, you can unshare your screen.
Yes, ma'am.
Hello, ma'am. Am I visible? My slides?
Yeah, slide is okay. Go ahead.
Okay. 1 minute, ma'am. Good afternoon, everyone. My name is Rakesh Kumar, and presently I am research scholar in IIT ISM Dhanbad. My area of research is connectivity restoration in wireless sensor network. I am going to present my paper with paper ID 310, and this is. So this is table of contents. First, I will start from introduction, then literature survey. Next, I will discuss about the problem, and then methodology to solve that problem. After that, result and discussion, and finally, I will conclude and conclude my presentation. So background, wireless sensor networks are formed with very small sensor devices with limited energy and short transmission ranges. Devices are deployed by two method. Maybe it may be random deployment or it may be a deterministic deployment. Random deployment. Multiple sensors are placed in the target area without any pre-calculation locations, while in deterministic deployment, some approaches are considered in which the proper location of the sensor are considered. When in a large scale wireless sensor network, multiple nodes fails in a simultaneously, it creates multiple partitions in the networks. So nodes belonging to the one partitions can communicate with nodes belonging to that partitions only, while the nodes belonging to one partition cannot communicate with the nodes belonging to the other partitions. In critical deployment area, our objective is to reconnect the network by deploying additional sensor nodes or a relay nodes in the network. A relay nodes is a type of sensor nodes which is having the comparatively more computational power as well as the transmission range. When we multiple different several research works are available that consider the 2D wireless sensor network. While in this work, I am considering the 3D wireless sensor networks. In 3D wireless sensor networks, when it is deployed in a rough surface or hilly area, multiple obstacles are there, and the obstacles also reduces the radio signals. And sometimes failure of nodes or the shortage of battery, multiple nodes fails and it creates partition in the networks. Different obstacles like large buildings or dense trees also affects the radio strength and connectivity. So deploying the sensor nodes to reconnect the network is a type of NP complete problem, and this is the basic theme of my work, where I have shown the a large network has been partitioned due to the damage. Damage could be any type, like earthquakes, floods, or like if we consider the battlegrounds, like blasting also creates multiple partitions. Here we can see 5 partitions have been created in the network, and the size of the partitions are not regular. So as well as the number of nodes belonging to each partition is not even. So next, literature survey. I have gone through the few papers. Some of them has been included in this presentation. The first one is considered the TT score, which has 2 phases, like contour based and the denodulate triangulation based deployment. Denodulate triangulation is a triangulation technique in where triangles are formed in such a way that whenever a circumcircle is drawn to any triangle, no other vertices lies inside that circle. The paper with reference to discuss the virtual force methodology, and this is also a 3D deployment based method, and it uses a distributed particle swarm optimization algorithm. Next is the deployment strategy for 3D terrains, that is in paper reference 3, and which is based on the wavelet transform. The fourth reference uses the divide and conquer strategy for the partitions networks, which to create a whole space into a collection of subcubes, and the objective is to maximize the size of the subcubes, so more number of nodes will be reside in there. And the fifth paper is the Brisbane line of sight coverage uses model for 3D environments, and it is used for reformalize the 3D WSN deployment problem, incorporate a realistic spectral model for the environment. So I'm going to explain my problem. So obstacle which are present in the network creates divides the network into multiple disconnected subnetworks. Radio signal also diminishes the obstacle due to obstacle. Radio signal of the nodes is not regularly available due to the 3D environment. If we use the mobile nodes for connectivity restoration, the problem with the mobile nodes is that it can get stuck in any rough surface, and also it can run out of the battery, and so the task of the network reconnection will not be completed. Sometimes visiting each nodes in the network is not possible for the mobile nodes because it creates unnecessary delay in the networks. So in my other paper which has been published, I have used some meeting points for collecting. After failure, random deployment is not suitable, and the optimal sensor deployment is in 3D plane is NV complete. So this line is redundantly placed in this slide. So this is the scenario I am showing: a hill area where multiple nodes are connected to each other, and we have assumed that their transmission is in a circular way. So the methodology I'm using is based on the de Nollet tetrahedron. The reason because that de Nollet tetrahedron provides us the very quality structure in a very less duration of time. A tetrahedron consists of the 4 triangles, 6 straight lines, and the 4 vertices. Tetrahedrons are formed by considering each partitions as a vertices. So what I mean to say is that suppose multiple partitions are there, there will be one representative nodes from each partition. Several research works are available to select the representative nodes, also known as the cluster head, from the partition. So I have not gone to that part of the problem. So one representative nodes will be selected from each partition, and that will be considered at the vertices of the tetrahedron that is being formed. We triangulate the area considering each partitions as a vertices. Then for each triangles, intermediate points are inserted on the edge. For indicating the intermediate points, we calculate the distance of √3 RS on each side of the triangle, where RS is the range of the sensor nodes. So here we can see a polyhedron that is formed by considering the representative nodes from each partitions. So here we can see P1, P2, P3, P4, and P5 are the 5 partitions representative nodes, and there one polyhedron has been formed. Now we are converting that polyhedron into a tetrahedron, and we can see that the 4 types of tetrahedron has been formed from. Now the task is to place the sensor nodes or relay nodes inside that tetrahedron. So based on the conditions, as we have already multiple intermediate points. So based on the condition of the transmission range, intermediate points will be selected. Maybe there may be few intermediate points which cannot be involved in the connectivity restoration process. We will ignore those intermediate points. So now the length of the triangle is considered in such a that it fits inside a sphere of the radius RS. As I said, RS is a range of the sensor nodes. We will place the sensor node at each circumcenter of the newly formed tetrahedron, and the distance between two consecutive intermediate points must satisfy the equation pk plus 1, that is two consecutive points, and the bar of this is the length of the side, and its cube must be less than the 8 root 2 pi rs whole cube. I have just wrote this equation with the concept that whenever we are considering the circumsphere of any tetrahedron, the volume of the tetrahedron must be less than the volume of the circumsphere. So here we can see multiple intermediate points are there for a polyhedron, and then we get the multiple tetrahedron by using the intermediate points which has been shown in the blue color. So this technique has been compared with the 3D grid cube based technique with the random deployment. I have considered the different fields. I have considered the two field size. First one is I have assumed the smaller, that is a 200 by 200 meter, and the second is the 400 by 400 meter. Then the network lifetime has been compared, since including the multiple intermediate points. Since including the multiple intermediate points will increase the number of hops for the packet transmission, and we know that when multiple hops are there, the packet will be encapsulated and decapsulated at those locations, and the node's energy will be involved there. So the overall network lifetime will be diminished. Now I conclude my work with that we propose a node placement for the connectivity of 3D wireless sensor networks, and the networks have been partitioned into multiple sub networks. Then the 3D space between the partitions is triangulated using the Denali tetrahedrons, and the circumcenter of the each tetrahedron is the probable location for the node placements. The references I have used is mentioned here. I have, that is the 5 references I have considered in this paper. And finally, thank you, sir.
आपको अपना पेपर प्रेजेंट करना है.
Ramesh,
yes sir.
How do you find the this algorithm for larger size network?
Sir, for a larger size network, multiple partitions are created. So for each partitions, one representative nodes will be selected, and those representative nodes will form a polyhedron. And now my task, the task of my proposed method is to splitting the polyhedron into a tetrahedron, and the constraint is that circum radius of the tetrahedron must be less than the transmission range of the sensor nodes. Yes, sir.
Storage factor. Yes. What is the average key storage factor?
Average
key storage.
Sorry, sir. What is key storage, sir? Sorry, sir. Hello.
You might be mentioning somewhere the unused keys, no? You must be minimizing the unused key and the.
No, sir. For the knowledge triangulation, I have used the Watson method that uses the flipping concept, incremental flipping concepts. So each vertices will be considered, and it will be checked whether it is satisfied the property of de-knowledge triangulation or not. If it is satisfied, then we will go ahead. Otherwise, it will be flipped. That only I used, sir.
Okay.
Yes, sir.
Yes. We have received one question from the participant. What is the distance between the node in your proposed work?
What is difference between what, sir?
Distance. What is the distance between the node in your proposed work?
Distance, sir. I have used I have used a random deployment, and the field size is fixed only. So, sir, if we are considering random deployment, the distance between the nodes will vary, sir, depending on the network area only. But it must be the more than the transmission range. Otherwise, it will be they will form a single partitions. So for disconnections, it must be more than their transmission range. Yes, sir.
Okay, that is up from my side.
Yes, sir. Thank you, sir.
Okay, Mr. Ramesh.
Yes, ma'am.
On which platform have you done this simulation?
Ma'am, I use the NetworkX package for Python.
Pardon? Come again? In Python?
Yes, ma'am. That is computational geometry method. For computational geometry method.
What are the libraries you have used in Python?
Ma'am, I used NetworkX package, NumPy, and NumPy NetworkX. That's only, ma'am, I think, for that work.
Okay. What are the average number of nodes that you would have in a tetrahedron? Generally, because you are going for a random deployment. So
yes,
you at the time of simulation, so what were the average number of nodes in one tetrahedron?
Ma'am, actually, in some other papers, suppose I use 500 by 500 field size. In that case, I used 200 nodes, for the deployment.
No. I'm not talking about the nodes to be deployed. Yes, I'm saying that you have formed the tetrahedrons, and then how many nodes on an average lie in one tetrahedron, or they are only on the vertices?
Yes, because that is the de-knowledge tetrahedron, ma'am. So there will be only four nodes each for four nodes.
That's what the question was. So if you have 200 nodes, then on an average you have how many tetrahedrons to be developed? So if you are saying there are 4 nodes in one tetrahedron, so there are somewhere around 50 tetrahedrons that you have made.
Okay, ma'am. One thing I would like to repeat, that I have not considered the all nodes. I have considered the one nodes from each partitions. So if there are 10 partitions, it may be 100 nodes, but the partition is 10 only. So there will be 10 vertices only in this work.
But you are not using all the nodes of the sensor network. That means.
Yes, ma'am. I am not using that. I have considered the one nodes from each partitions.
But then the efficiency of your proposed work would be reduced considerably if you are not using all the nodes of the network.
But ma'am,
then why are you deploying so many nodes then in that case?
No, I have not deployed, ma'am. I have used the field size.
You have gone for a random deployment, no? So then why are you using so many nodes for the deployment? If you are not using all the nodes?
Because, ma'am, for selecting the you asked, ma'am, about the efficiency. The representative nodes will be selected, and it will decide the efficiency of the method. If we select the wrong representative nodes, obviously the efficiency will be fall down.
No. My question was something different. Okay, fine, it is. My question was, you were saying that you are taking only some of the nodes to form the tetrahedron. So some of the nodes would not be there a part of tetrahedron.
Yes, ma'am.
Or you are saying the tetrahedron nodes would be the ones which would be the representatives. Is that so?
Yes. Tetrahedron vertices will be the nodes of representative nodes only.
So, but you said that those nodes will have a greater transmission power. So how will you know that only these nodes have higher transmission power? Because these are somewhat like cluster heads.
No, ma'am. That was a relay concept. That time I was.
I got your point, Ramesh. I got your point, Ramesh. The only thing is that when these nodes are only there as representatives, so they would be doing the communications and transmissions.
Yes.
So they should be having some extra power as compared to the rest of the nodes.
No, ma'am. Ma'am.
Is it required or not?
Not necessarily. It depends, ma'am, what we are using additionally. Suppose we are using additional sensor nodes, it will be their transmission power will be same. But if we are using the additional relay nodes, so obviously relay has the more computational and transmission power. Yes, ma'am.
So then you will make the tetrahedron only with the relay nodes in that case.
Yes, that's what I'm saying, ma'am. The position, the location I found.
Got the point, Ramesh.
Yes,
it's
ma'am.
fine.
Thank you, ma'am. Thank you.
That's it from my side.
Thank you, ma'am.
No question from my side, so you can go ahead.
Thank you, sir. Thank you.
Mr. Ramesh, you can unshare your screen.
Okay. Yes, ma'am. Sure.
I would like to request all the session chair to fill the evaluation form that has been sent to a mail so that we can finalize the best paper award. Now, I would like to invite our last presenter, that is the paper ID 396, Mr. Nipin Kumar. You can share your screen and start the presentation. Mr. Nipin, your voice is not coming. Is it audible to all?
No,
no.
It's not audible.
Hello, am I audible?
Yes, no,
Hello.
it's fine. Yeah, fine.
Hello.
Yes, fine.
Yes, you are audible, sir.
Hello.
Yes, sir, you are audible. You can share your screen. Again, there is issue with your audio.
Hello, ma'am.
Yeah, yeah, it is fine now.
Okay.
Good afternoon, everyone. My name is Nirpendra Kumar, and currently I am pursuing my MTech from NIT Patna, and I have done this research work under the supervision of Dr. Diti Priya Sinha ma'am. And my today's presentation topic is energy efficient cluster head selection mechanism using fuzzy-based system in WSA. So these are the outlines of my presentation. At first, I am going to give a little introduction about background and literature that problems, result, and discussions, and the conclusion. And at then I'm going to show the references. So is the wireless sensor network. So basically, we randomly deploy some sensor node, and they all try to collect data from their surroundings and they send their data to base stations, and with the help of internet, user can access that data and try to optimize that data whatever they have to need. So basically, in my proposed work, I'm going to minimize the battery consumption and try to increase the network lifetime. So here is the literature survey. The first one is the probability-based clustering routing protocol. So in this paper, they use residual energy and initial energy to find the cluster head selections. And they use probability functions. So I can say that they may increase the uncertainty. And the second one is fuzzy-based novel clustering technique. So they use correlational functions and try to calculate the all sensor nodes correlational value. And with the help of certain user-defined threshold value, they just try to compare every node, and whomever the node the correlation value is less, so they simply put that sensor node in a sleep mode. So here also they use a required energy, so they use a kind of reduction. So I think that may it not give that much output. And the third one is an energy resourceful clustering technique. So in this technique, they use node mobility.
So your presentation got stuck. Kindly check your connection.
Like in a output functions, and they give the result 0.42. So in my work, I just take that 0.56 as a if we get the value greater than 0.56, so that node will going to be the cluster head. So it's that node was not able to fulfill the requirement, so that node is not going to be the cluster head. And also here you can see that mean max. So it makes mean max, like if we take the value from here, like in this range from 0.2 to 0.3, so at that time, like that the low function will also call, and at the time also that medium function will call also. So at the time we have two values for that. So here we are going to take the minimum value for that, and after we just generate this all all output for input variables. So at the time that the maximum value will going to be considered. Here is the results. So I compare my proposed work with FBCS and BCS and Leach also. So we get that result, like for average residual energy, our like my proposed work. So they have a more residual energy after 100 rounds, or after 200 rounds, and after 500 rounds also. And the number of cluster head formation, like they also shows like in my proposed work, they select more cluster head, and that's the result analysis. And is the conclusion, like a fuzzy based cluster selection technique is designed, and we take 4 input parameters: residual energy, node to base station distance, and node to node distance, and the last one is a degree as input, and a cluster head value we take as output. So most eligible node is selected as a cluster head, and it will enhance the lifetime of the network. These are the references. Thank you. Thank you, sir.
Any question from session chair?
Yes. Mr. Nripendra.
Yes, ma'am.
When you were saying that you were using the fuzzy logic, then basically you had 4 parameters. And if you have taken that medium function, and after that you decide whether it would be a part of a cluster head or not. This is what you're trying to say, whether it would be a cluster head or not.
Yes, ma'am.
So if node comes, if it is close to 1, then you would say it is cluster head. So what is the threshold for the cluster head? If the value of all the 4 parameters exceeds what, you would say it is a cluster head.
So, ma'am, basically in my work, I take that 0.56 as a threshold value because
How did you come to this value?
Ma'am, I analyze all those values. Like we generate a table for every sensor node. They get that the fuzzy-based system.
The main thing
output.
is about the threshold 0.56. It could have been 0.6 also. It could be have 0.65 also. So how did you come to this number 0.56?
Because ma'am, I just want to select a more efficient node, and the number of cluster head also I want to increase. So that's why on the basis of that, I just analyze after 100 round and after 200 round, like how they are going to give the value like that.
Did you try with other values? Did you try with 0.45 and 0.4 or
yes,
0.65?
Yes, ma'am.
What are the results with that?
So, ma'am, if I just take that 0.46, so they try to select like approx 30 node are eligible for cluster head. So that's why, yes, ma'am.
So could you plot the graphs and everything? What is the residual energy after choosing 0.46 as a threshold value?
Yes,
because this is very very fuzzy in itself. Okay, how do you choose 0.56? You change the value, some other person can change the different value and may get the different result.
Yes,
isn't it?
Yes.
And go back to your previous slides in which you were showing the triangulation graphs. The medium, there also you chose some random values. Here, 0.7 and 0.8. How did you come to these values?
Yes, ma'am. I just select those randomly. Like if I just say that low, so there must be a in the range
you cannot
of
choose
0
random
to
values
0.
like this, until unless you have some background on that. Either you should have domain knowledge or there should be some research. And where did you do the experimentations? MATLAB.
Ma'am, yes, ma'am, on MATLAB.
Yes, so MATLAB will not be able to simulate that. That's the thing. You have chosen these are the basis of your proposed work, and if you change the values, and accordingly your results are going to change.
Yes, ma'am, but if
Think
we just take yes, ma'am.
Okay, think over it, I said.
Yes, ma'am. Sure, ma'am.
Okay, that's it from my side.
Thank you, ma'am.
Dependra, actually, I was going through a presentation, and now I found that there are many papers related to the fuzzy-based clustering approach. And the approach that you discussed is almost similar to the approach which are available. So how your approach is different from other, because you are also computing, also identifying the cluster head, and then you are assigning the nodes to a particular cluster on the basis of the threshold. To discuss that you are taking the threshold value 0.56, and that was also my concern, how you get to that particular value 0.56, because this could be anything. This could be 0.9, this could be 0.6, this could be 0.4. So this is one aspect that I want to ask. And second, how your research is different from the research that is being already published, because if I open Google Scholar, then I'll find the similar I find a similar approach. So is there any difference in I can say that the formulation, how you are computing this threshold value, or how you are identifying the cluster head, or how clusters are being formed? Everything is very different, very much important. But in your case, you are just taking the factors which are proposed by the researchers, earlier researchers.
No, sir. Basically, sir, in my work, I take that node to node distance. So I wrote like approx 10 research papers. So in that they did not mention that node to node distance. So I considered that part in my work, and for like how I come up with that threshold value. So I just analyze all those values, because sir, like for 100 nodes, if I just consider the 100 nodes, so we have a 100 cross. If I just run that code for 100 times. So we have 100 cross 100 matrix, and we have that much data. So I analyze that data, like and I just try to match my requirement. Like I just want to make 23 node, as I said.
So what will be the membership function for your approach, and what will be the complexity, computational complexity? Could you please mention?
Yes, sir. In my approach, I use triangular membership functions.
You are using a triangular membership function for computing this threshold value or the membership.
No, so for not yes, sir. For cluster head value, sir.
For cluster head selection.
Right? For yes, sir.
Okay. And what would be the complexity of your algorithm? Or suppose we have 1 million of node or 10,000 of node. In that case, what will be the overall complexity in the terms of n?
Yes, sir. Basically, in this work, we use for one for loop for try to simulate that that. Here is the big of, and I can say that, and for fuzzy base, it will take also time, sir. So maybe
so please think over it. Okay.
Yes, sure.
Okay. Thank you all. Thank you, everyone. That's all from my side.
Thank you, sir.
Okay, Mr. Nifi, you can unshare your screen.
Yes, sure.
With this, we have completed all the paper presentation of this session today. Now I take this opportunity on behalf of NIT Raipur and organizing committee of the conference. I thank you all for sparing valuable time as well as providing valuable insight to the authors. Thank you one and all for making this session successful. Now you can log out of this session. Have a nice day.
Thank you, everyone.
Thank you, Avinash sir. Thank you, Rajesh sir.
Thank you, ma'am. Thank you very much.
Thank you.